Hi, and welcome back to Grade 8 Math. This is Section 3, Lesson 2, and the first video for this lesson. This is Ms. Clemens Brenton, and today we will look at how to calculate the probability of independent events. We can use the sample space created when using tables and tree diagrams to determine probability. For example, the sample space when tossing two coins was heads and heads, heads and tails, tails and heads, and tails and tails. From this, we can easily determine that the probability of tossing two heads is 1 over 4, since there were 4 different outcomes and only one outcome that had two heads. We can also calculate probability by multiplying the probabilities from each individual event. For example, the probability of getting heads and heads would be the probability of heads on toss 1 times the probability of heads on toss 2. So in this case, the probability of getting heads on toss 1 is 1 out of 2. The probability of getting heads on toss 2 is 1 out of 2, and we multiply those together to get 1 over 4, which was the probability we determined using our sample space above. When the outcome of one event is not affected by the outcome of another event, the two events are said to be independent. For example, I have 6 gumballs. What is the probability of picking a pink gumball, putting it back, and then picking a purple gumball? Well, the probability of picking a pink gumball would be 1 out of 6 because there's one pink gumball and there are 6 gumballs in total. The probability of picking a purple gumball would be 2 out of 6 because there are 2 purple gumballs and 6 gumballs in total. 2 out of 6 can be reduced to 1 over 3. We would then take the probability of each of those events and we would multiply them to get the probability of picking a pink, putting it back, and then picking a purple. So I would take 1 over 6 and multiply it by 1 over 3. So then the probability of picking a pink and then getting a purple would be 1 over 18. Likewise, when we toss one coin and then toss another coin, the result of the first toss has no impact on the result of the second. Similarly, the color a spinner lands on has no bearing on whether a coin lands on heads or tails. However, when the results of one event affects the outcome of another event, these events are said to be dependent. Let's think about that for a second. How do you think the probability would change if a pink gumball was selected and eaten, and then a purple gumball was selected? Well, the probability of picking a pink gumball would still be 1 over 6, but then because we eat that gumball, the probability of picking a purple gumball then becomes 2 over 5. So 1 over 6 times 2 over 5 becomes 2 over 30, which then reduces to 1 over 15. So we can see that the probability of the second event is impacted by what happened in the first. Think about the following events and determine whether or not they're independent or dependent. So remember, independent events is when one has no impact or bearing on the other, and dependent events is when one event directly impacts what happens in the next. Failing to study for a test and receiving 50% on the test. That would definitely be dependent events. If I don't study for a test, I'm probably not going to do very well. Choosing a marble from a jar and tossing heads on a coin. Well, whatever color marble I choose from a jar is not going to impact whether I toss heads or tails on a coin, so that would be independent events. Tossing heads on a coin and rolling a 5 on a 6-sided die. Again, whatever I toss on a coin has no impact on what I roll on a die, so those would be independent events. Rolling a 5 on a die and it's raining outside. Whatever I roll on a die is not going to impact the weather, so those are independent events. Waking up late and missing the bus. Well, if I wake up late, chances are my day and my schedule is going to be thrown off, so those would definitely be dependent events. It's sunny outside and going for a bike ride. Well, we usually don't go for bike rides unless it's nice outside, so those would be dependent events. Example 1. The letters of the word vacation are put into a bag. Find each probability. What's the probability of picking a V? So I would write probability of picking a V. So I'd look at my word and I can see that there is one V out of 8 letters in total. So the probability of picking a V is 1 over 8. What's the probability of picking an A? So I would write probability of picking an A, P of A, and I have 2 A's and 8 letters in total. So that's 2 out of 8, and that can reduce to 1 over 4. What's the probability of picking a T followed by a vowel? So I write P of T and vowel. So I can see in my word I have 1 T, so that's 1 out of 8, multiplied by the number of times I see a vowel. So I see 2 A's, an I, and an O, so that's 4 out of 8. And before I multiply those, I'm going to reduce that 4 over 8, so that would become 1 over 8 times 1 over 2, and then that becomes 1 over 16. So the probability of picking a T and then followed by a vowel is 1 over 16. What's the probability of picking a B? So probability of picking a B, so I count how many B's. Well, I don't see any B's, so that's 0 out of 8, so we have no chance of picking a B. Example 2. A bag contains 4 red, 3 purple, and 6 blue marbles. Jesse picks a marble, returns to the bag, and then picks another. What is the probability he picks a purple marble both times? So I write probability of purple, and then purple again, and I find the probability of each of those independent events and I multiply them. So the probability of picking a purple marble would be 3 out of 13. We add up how many marbles we have in total, so 4, 3, and 6, so that gives me 13. And then I multiply it by the probability of purple again, which is 3 out of 13. And that gives me 9 out of 169. So the probability of him picking a purple and then another purple marble would be 9 out of 169. What's the probability that he picks a marble that is not blue and then picks a red? So the probability of not blue followed by red would be 7, because there are 6 that are blue and 7 that aren't. So that's 7 out of 13 multiplied by the probability of picking a red. And there are 4 red over 13. So then I multiply those. So 7 times 4 gives me 28. And 13 times 13 gives me 169. So the probability of not picking a blue and then picking a red would be 28 over 169. What's the probability that he picks a purple and then picks an orange? So the probability of picking purple and then picking orange, we find the probability of each independent event. So the probability of purple would be 3 out of 13, and the probability of picking an orange is 0 out of 13. So again, there are no chances that he will pick a purple and an orange. 3 times 0 is 0. So it's 0 out of 169. So there's no chance he'll pick purple and then orange. Please complete the activities for this lesson.